composition. You have to be able to do this. And this was really hard for a lot of you. A lot of you you missed this on that quiz we took. So, first of all, we're given two functions. F of x is equal to x minus 3 squared. G of x is equal to 2x minus 3. We're asked to find GO f of x. Now, that little O, is that a multiplication sign? No, it's very, very different. So, very important. So, we'll rewrite this. Does anyone remember the little trick? We squish x back in with our f, right? Which would be f of, which would be f of x. Then we squish it back in one more time, back into G. Does everybody remember that little trick? So now it's easy to see which one we're substituting in. So we're substituting in the inside, right? Now a lot of people can't figure it out. Guys, it's inside the parentheses, that's what we're substituting in. So I locate that. Does everybody see how I locate that and circle it? I'm substituting that into the other function wherever there's a variable. Now is that variable there anymore? No, a lot of people are still multiplying things, and they shouldn't be. We're plugging it in. So there's not an x anymore. Instead of an x, we're substituting in f. So we're going to have 2 times what we're substituting in, which is x minus 3 squared. Does everybody understand that? And then we have minus 3. Does everybody see where the substitution happened, yes or no? So we're all okay. All right. So, any questions? All right, then we could continue to simplify this. We could continue to simplify this if necessary. I don't think I'm going to take the time to do that today. So we're all okay with function composition. That was a good review problem. All right, very good. In fact, that's not a horrible looking function. I might even accept that as an answer. It just depends on the problem. All right, so guys, we have a test coming up this week. Learned a lot. So in 3-1, we were learning how to solve radical equations. So with this one, does anyone remember the first rule? The first rule to solving a radical. Good. Yeah, say it. Somebody back here. Isolate the radical. Okay, so I'm going to add the square root of 5x plus 5 to both sides of the equation. So over here, I can't write in there, it's too little. Okay, so over here on the left, that went to 0, which is the whole point. So we have the square root of 3x minus 2 is equal to 0 plus this is just this. So we have the square root of 5x plus 5. Is everybody okay and comfortable with that? We've isolated the radical on one side of the equation, and on the other side of the equation, there's an isolated radical. Then what will we do to get rid of the radical? Good. The inverse of the square root is the square. So we're going to square both sides of the equation. So our root cancels out with our power. Our root cancels out with our power, leaving us with 3x minus 2 is equal to 5x plus 5. And now we're just down to linear solving here. We'll get x alone. So let's combine our x's. So I'm going to subtract 3x from both sides. Now once again, check your work. Yep, that added up to be 0. So negative 2 is equal to 2x, right? 5x minus 3x is 2x plus 5. Then we'll solve for x. So we have negative 7 is equal to 2x, right? Divide both sides by 2. So x is equal to negative 7/2. Is everybody okay with that problem? Okay, and then we would check our answer by plugging it back in and making sure it's not an extraneous solution. All right, in 3-2, we learned how to do function operations. So given these two functions, like you don't have to be taking notes during this time. This is all review. Just getting you remembering what we've learned. Let's do each of these. J times P of x. This one's times. So J of x is equal to what? 4 minus x. And we're going to times it to P of x, which is x squared plus 2. Right? That's J of x times P of x. Are you confused over there? You don't have questions? Okay. So then we're going to distribute, right? 4 times x squared is 4x squared. 4 times 2 plus 8. Negative x times x squared. Negative x cubed, good call. And then negative x times 2. Negative 2x, we'll combine like terms. In fact, we'll combine like terms and put it in standard form. So what's my highest degree? X cubed. So negative x cubed. And then we have plus 4x squared. And then we have minus 2x. And then we have plus 8. Does everybody understand how to put it in standard form? Okay. Do I not need to go over review problems? Is this making some of you mad, or are you all okay with me going over some review problems? I thought it would be good, considering we've learned everything. Would you rather me just get to the lesson? So you want me to continue? Okay. All right, P of x minus J of x. This one's a tricky one. What is P of x? X squared plus 2, and then we're subtracting all of J of x. So isn't this the one we need to put in parentheses? Yes, this is the one that's most missed on the test. So minus J of x, which is 4 minus x. Does everybody understand why I put the parentheses in there? When subtracting, we've got to subtract all of it, because that's all of J of x, so we put it in parentheses. So then we'll go ahead and distribute negative 1 through. Negative 1 times 4 is negative 4. Negative 1 times negative x plus x. We drop this down, so it was 2, and then x squared. Combine like terms. So x squared is the highest one, and then we have plus x, and then what's 2 minus 4? Negative 2. Very good. In standard form. That is P of x minus J of x. Any questions on that? Okay? Alright, and then in 3-3, we learned to find the inverse and then domain and range. I think I'm going to skip the domain and range part, because I want to give us plenty of time for the lesson. So given f of x is this. Let's find the inverse. So the first thing I do is rewrite it as a y. F of x is y, guys. It's just a more correct way, more advanced way of saying we have a function of x. So y is equal to 3x minus 1 squared minus 3. What's our first step in finding an inverse? Good. Switch x and y. X is equal to 3y minus 1 squared minus 3. And then algebraically, piece by piece, we'll solve for y. So what am I going to do? Very good. First step is add 3. Now order matters with this, so good. X plus 3 is equal to 3y minus 1 squared. Very good. Then we'll take the square root of both sides. And what do we have to account for when we take the square root? Plus and minus. Okay, so our root cancels out our power. So we have plus and minus. The square root of x plus 3 is equal to 3y minus 1. Then what? Good. Add 1 to both sides. Can I add the 1 underneath? No. So we have plus and minus the square root of x plus 3 in parentheses. And now we have, And now we have, sorry, I wrote that really hideous and funny. Okay, so we have plus and minus the square root of x plus 3. And then we have plus 1 is equal to 3y, right? Then we will what? Divide both entire sides by 3. Yeah? Okay, good. So then we have y alone. So our inverse is this. So you write it properly. F inverse of x is equal to plus and minus. If I wrote it like this and it was multiple choice, let's see if you would think it is the same thing. Is this the same thing as that? Yeah. I didn't make any errors here. Didn't I say, well, it's all that stuff divided by 3. Isn't all that stuff still divided by 3? Okay. So, there you go. Very good, guys. So we're good with inverses. You guys are getting better. That's awesome. All right. And then 3-4, we learned how to solve rational equations. So what do we have to do with these? Get a common what? The least common denominator. So this one has an x plus 2. That's going to be part of it. This is the one that threw people off. What about this 2? Can we magically make it x plus 2? No, right? There's no magic way. So x plus 2 and 2 has to come. And then this one, we already have an x plus 2 listed, right? So what do we need to multiply this one by? So if you do that to the bottom, you've got to do it to the top. What do we need to multiply this one by? So if you do that to the bottom, x plus 2, you'll do it to the top, x plus 2. And what do we need to multiply this one by? So 2 over 2. Are our bottoms the same exactly? So now we can ignore them and just use the top to solve, right? So we have 2 times 2 is 4. And then right here, before we take this, isn't this subtraction all of this? Yeah. So let's actually make this instead. Let's go like this. -3. Is everybody okay with that? So let's distribute -3. -3 times x And then negative 3 times 2. Negative 6, which is equal to x times 2. 2x. Can't we solve for x from here? It's linear, so don't let it throw you off. Add 3x to both sides, right? So on the left, we have 4 minus 6, which is negative 2 is equal to 5x, right? And then divide both sides by 5. So x is equal to negative 2 over 5. Yay. Okay. So that's all I'm going to go over. Very good. So we'll get to the lesson for today. Here we go. Okay, so just good review. Guys, I just wanted to make sure we're good because like I said, we're learning today's lesson, tomorrow's lesson, and then it's the review. Okay. So 3-8, today we're going to be doing applications, story problems of exponentials and log equations. Now, don't let the word story problem scare you. A lot of these are actually quite easier than anything we've done. So if you pay close attention, then you'll get it. If you don't, though, you're not going to even have a clue on how to begin these. So, but they're very important, okay? So, recall that we have talked about exponential growth and decay, right? And exponential functions have the form f of x is equal to a times b raised to the x, where a is the initial value, the starting amount, right? B is our growth or decay factor. Is everybody good with that? And then x is the time in, the input. Now, can anyone remember when b is greater than 1, do we have growth or decay? Growth, right? Exponential growth. And then if b is less than 1, we have exponential decay. And that only matters for b. B is what determines growth and decay, right? Okay. All right, so if you all remember that, then we'll be good. So we'll do our first example. We've actually done problems like this already this year. So it says, suppose you invest $200 in a bank account that pays 4% annual interest. How much will be in your account in 10 years? So guys, this is exponential growth. So this is exponential growth. Interest is growing exponentially. So we know, first of all, that the function for exponential growth is f of x is equal to a times b raised to the x, where a is our initial value. What's our initial value? How much initially do we have? $200. Does everybody see how we have $200 initially? And then b, what's our growth or decay factor? Okay, so we're getting 100% of our worth, right? Since it's growing, we're getting 100% of our worth plus an additional what? Plus an additional 4%. So technically, we're making 104%, right? Now, that is our growth factor, but we have to write it as a decimal. Now, remember that you can move it 2 decimal places, so this is technically 104.0%. Now, we move it 2 places. Does everybody see how to do that? So you can do it properly. So that is 1.04. That's how we write 104%. So 1.04 raised to the x power. There's the function. How much time are we talking here? 10 years. So now the time in is 10. Plug it into your calculator. So 296 and 4 cents. Okay, so that's how much we have. So how much did we earn? Just curious. So it says how much will be in your account. How much did we earn? Well, we started with 200. We now have 296. So we earned $96.04 in interest. Now, interesting enough, if you like this kind of thing, guys, you could go on and become an actuary. I met an actuary this weekend, and he is like a millionaire. So he works in Vegas. It's a mathematical thing. They work for insurance companies. They make predictions, and he has like this huge mansion. It was pretty cool to talk to him. So anyways, you could become an actuary if you like this kind of stuff. All right, so let's do one more. Suppose you invest $200 in a savings account that pays 6% annual interest rate. If you make no additional deposits or withdrawals, how many years, so this one's a little bit different, how many years will it take you to get $2,600? Okay, so we know this is exponential growth. So we know the function is f of x is equal to a times b raised to the x. Okay, what's our initial value? 2,000. Does everybody see how I'm just putting it in? And then it says an account that pays 6% interest. So what will it be? 1.06. That's 106%. Does everybody understand how I did that? Skip a step. Is everybody okay? raised to the x power, it says if you make no additional deposits or withdrawals, how many years will it take you to get $2,600? So in the end, we're talking 2,600, right? Does everybody understand that? So now we're saying 2,600 is equal to this, right? So now we're trying to find how much time. So does everybody understand why that's solving for x? How much time? Okay, so we know how to solve these. Isn't that just an exponential equation? We know how to solve exponential equations. We have to isolate the base. So how am I going to get the base along? First step. Good. Divide both sides by 2,000. So then we have 2,600 over 2,000 is equal to 1.06 raised to the x power. We've isolated the base. Then how do you undo the base? What is the inverse of exponentials, guys? Logarithms. So we have base 1.06. So wouldn't we take log of the base? 1.06 of both sides. Are you guys following me? So then on the left, we have this, and on the right, our base, log of the base 1.06 and base 1.06 cancel out. So we have it equal to x. So we have log of 1.06, and then if you wanted to, you could calculate that. So you have 2,600 divided by 2,000, and you get 1.3. Okay, now do we know how to type this into our calculator? It has to be base 10, right? So we use the change of base formula. So we're going to rewrite this as log of what? 1.3 divided by log of what? 1.06. Are you all remembering the change of base formula? I'm feeling very concerned right now. Okay, then type that into your calculator. So you have log of 1.3 divided by log of 1.06, and you get 4.5. So 4.5 years. So it's equal to x. So 4.5 years. That's how long it's going to take you to make $2,600. 4.5 years. Does that make sense, everybody? Yeah. I took this divided by this. Yeah. This divided by this is 1.3. Does everybody get how to do it? So I'm not going to do another example. I'm going to let you practice. Are you ready? Okay. So do 1 through 3. Ready, set, go. Example here. So remember that if you're given a problem where it says in there that you're compounding continuously, this is the time keyword compounding continuously. Anytime you see that, you have to know that this is the formula for interest rate when compounding continuous. So you're looking at this, it's A is equal to P times E raised to the RT. So PERT. Now remember the R and the T are up in the exponent, so don't forget that. So A is the end amount, P is the put down, the initial amount. Now this is just an exponential equation just like we did before. E is just a number, but we'll use our E button on our calculator. Remember that E is just approximately 2.7. So like I said, we'll use the E button on our calculator. R is the rate of interest, and T is the time in. So this looks just like any other exponential function. I mean, a little different, but the same thing. Do you all have PERT? Down. Okay. So here's my first example. It says, suppose you invest $1,000 in a savings account that pays 5% interest compounding continuously. Now, compounding continuously, they're not going to say to you, I'm not going to say to you on the test, okay, use PERT, you're going to have to know that. When you see the word compound continuously, you know. So how much will you have in 2 years? So A is equal to P times E raised to the RT. All right, so then I just fill it in piece by piece. What's my put down amount? 1,000 times E raised to the R. What's my rate? 5%. Now understand something. With this one, it pays 5% interest. You're not going to use, it's not the same as exponential growth and decay. 5%, you just type in exactly how it is. So that's going to be 0.05. Okay, so you with PERT, you don't do the exponential, it's not exponential growth. The PERT is taking care of exponential compounding interest. So your rate is just going to be 0.05. Do you all understand that? So with PERT, you just use the decimal for the percent they give you. So 0.05 is our rate, so 0.05, that's 5%, and then it says in 2 years, so T times 2. So then you'll just type it into your calculator, 1,000 times E, second ln on your calculator, 0.05 times 2. Hit enter, you get $1,105.17. So that's how much you'll have in 2 years. Does that make sense, everybody? Okay. Okay, next one that I'm going to let you work. If you end up with $300 in a savings account that pays 4.5% compounding continuously for 6 years, how much money was originally put into the account? So because we saw compounding continuously, we know that we're going to be using PERT. A is equal to P times E raised to the RT. Okay, so now putting in what we know. So it says you end up with $300. So in the end, we get $300. Is that the put down amount? No, that's how much we ended with. So the $300 goes right there. So we have 300 is equal to, now it says how much money was originally put into the account. So we're going to be finding P. That's the put down amount. And then E is just a number raised to the R. The rate is 4.5%. So as a decimal, that's 0.045. And then times 6 years. Very good. So times 6. So now let's think about this, guys. How do we get P along? Divide by E raised to that. Is there any variable in there? No, we can just calculate that. So divide both sides by E raised to the 0.05 times 6. Sorry, times 6. Divide both sides by E raised to the 0.05 times 6. So times 6. Then you take your calculator. 300 divided by second E raised to the 0.0. Those are parentheses. Sorry. 0.045 times 6. And you get 229.01. So 01. So that's pretty much $229, yeah? Does everybody understand how we had originally put in $229? Are we all okay with that? Okay, so then it says, how long will it take for the original amount to double? So originally we had 229, right? So how long will it take for it to double? So let's double 229. 229 times 2, right? That's double. So double is 458. So now we can plug it in. A, the amount at the end is 458. That's how much is double. 458 is equal to the put down amount is 229. And then we have E, because it is compounding continuously, raised to the 0.045, then times T. Because it says how long, so how much time is it going to take for the amount to double? So does everybody see how I chose to double it and then just plug it in? Yes or no? Okay. Awesome. So then we'll go ahead and solve for T. So first things first, we'll divide both sides by 229. So we have 458 divided by 229 is equal to E raised to the 0.045T. Can anyone remember how to undo E? Good. ln is the inverse of E. So we'll take the ln of both sides. So then on the right, ln and E undo each other. So we have ln of 458 divided by 229 is equal to 0.045 times T. So then to get T along, divide both sides by 0.045. 0.045. So then T is equal to that. Calculate it. You'll do ln of 458 divided by 229. Make sure you practice typing it in so you know you're typing it in right when you get the same answer as me. And then divided by 0.045, so 15.4. So time is 15.4, and if we're talking years, which I think we are. So So it's going to take 15.4 years for you to double your amount. Does everybody see how to do that one? You're going to be tested on it. So, all right, so do 4 and 5. Practice it on your own. All right, so next problem. It says, a population of dogs is decreasing in a neighborhood. In 2013, there were 25 dogs. In 2015, there are 10 dogs. If the trend continues, how many dogs will there be in 2017? Okay, so they're decreasing, right? The dogs are decreasing. So it's exponential decay. So our dogs are decreasing in a neighborhood. So we know that exponential decay has the form f of x is equal to a times b raised to the x. Okay, so with this one, guys, first of all, okay. First things first, did we see anything about a rate? Do we know what percent it went down? So we had I'm struggling here. So in 2013, there were 25 dogs, right? And in 2015, and that's within, I meant to say 2014. So this is 2014. There are 10 dogs, right? So basically we're saying 25 times what equals 10. Because we're trying to figure out what rate we're decreasing. So 25 times, I'm not going to write that times, I'm just going to say 25 times question mark is equal to 10. What did we multiply 25 by to get to 10? So how do we solve for question mark? Divide both sides by 25. Very good. So we're trying to, do you see how I'm finding out the rate here? How do we get from 25 clear down to 10? What did we multiply by? So then 10 divided by 25. So we get 0.4. Question mark is 0.4. So does everybody understand how the rate was decreasing by 0.4? Are we all okay with that? You all get it? Okay, so our rate is 0.4. So we're decreasing by 0.4. And then our initial amount was what? How many dogs initially? 25, very good. And then it says, how many dogs were there in 2017? So how much time has gone by from 2013 to 2017? 17 minus 13 is? So, no, 2013, 14, 15, 16, 17, right? 4 years. Does everybody understand why the time in is 4 years? So then you'll type that in, 25 times 0.4, 25 times 0.4 raised to the 4th power. And you get let me type this in again, using parentheses correctly. 0.4 raised to the 4. So 0.64. So there are any dogs left? No dogs. So no dogs left in 2017. It was exponentially decreasing too much. Okay? Do you see how I found the rate first of all? How did we drop in? How many did we drop in 1 year? From 2013 to 2014, there was 25 dogs, went down to 10. So what rates did we decrease? I figured it out, and then that was my rate overall. So then I went through. All right, questions on that one? I didn't explain that one very good, I'll be honest. Do number 6. Okay, guys. Remember how I told you back when we were first learning logs and exponentials that there's a lot of real-world application? So we talked about how logs, guys, I'm ready. You're not going to know how to do this. So we talked about how earthquakes are actually, they're measured on a logarithmic scale. So this is true. In the real world, these scientists, they measure how intense an earthquake is using this formula. So I will give you on the test the formulas. I'll write them. I'll write them on the board. But you'll have to be able to look at the problem and know which one to use. Does that sound fair? Yes. Okay. So this is the formula for measuring magnitude and intensity levels of an earthquake. So we have log of intensity 1 divided by intensity 2 is equal to the magnitude of 1 minus the magnitude of 2. This is truly the formula used in the real world. So does everybody have that written down? Well, it's on the front page of your worksheet anyway. Okay, are you ready to pay attention to the first example? Yeah. Okay. So number 7, I'm going through it with you. In December 2004, an earthquake with magnitude 9.3 on the Richter scale. 9.3 on the Richter scale. The Richter scale is a logarithmic base. So a magnitude of 9.3 on the Richter scale hit off the northwest coast of Sumatra. Another hit Sumatra in March of 2005 with a magnitude of 8.7 on the Richter scale. How many times more intense was the December earthquake than the March earthquake? Now these are some of the easiest problems that you're going to see on the test. You have to just know how to do them though. Okay, so we have log of, okay, first of all, what was the magnitude? Okay, so magnitude 1, weren't we given that? It was 9.3. Magnitude 2 was 8.7. Let's plug that in. So we have log of intensity 1 divided by intensity 2 is equal to magnitude 1, which is 9.3, minus magnitude 2, 8.7. So then we'll continue to simplify. We have log of intensity 1 divided by intensity 2 is equal to, if you do that in your calculator, you get 0.6. So 0.6. Now we want to know the intensities. So we're trying to solve for I, intensities. So we've got to get log to go away. So what base is log? 10. So how do we undo log of the base 10? Take base 10 of both sides. Is everybody following me? So base 10 and log of the base 10 are gone. We have intensity 1 divided by intensity 2 is equal to 10 to the 0.6 power. If you type that into your calculator, you get 4. So guys, if you think about it, if we wanted to get intensity 1 all by itself, we would multiply both sides by intensity 2, right? Intensity 2. Does everybody see what I did there? So intensity 1 is equal to 4 times intensity 2. So how many times more intense was intensity 1? 4 times. So the answer is 4 times. It's 4 times more intense. Does that make sense? I1 was equal to 4 times intensity 2. So it's 4 times more intense. Cool. Does everybody see how to do that?
Yes.
Okay, awesome. Do 8 and 9. Same exact thing. Okay, guys, so here is, I told you also with logs and exponentials that also acidity level, some scientists use, well, this is the formula used to determine pH levels with hydrogen plus ions. So, acidity levels are measured in pH. So, to determine how acidic something is, it's on a pH scale, so then a scientist will compare, but you can calculate the pH levels by this formula. Okay, yo, are you listening?
Yeah.
Negative log of H plus. So a couple things, this is pH. H plus is just the number of hydrogen ions, so the number of hydrogen ions. So now we'll just go ahead and do our first example. Does everybody have the formula? It's on the front of your worksheet.
Yes.
Okay, so here we go. Okay, the concentration of hydrogen ions of a substance of Coke is 2.3 times 10 raised to the negative 2. And the concentration of hydrogen ions of Sprite is 13 to the negative 5. What's the difference of pH levels of Coke versus Sprite? So we know that the formula is pH is equal to negative log of H plus. Okay, so now I'm just going to plug it in. So we're comparing Coke versus Sprite. So the pH levels of Coke will be equal to negative log of the H plus, which is, now it says hydrogen ions, that is H plus. So that's 2.3 times 10 to the negative 2. Now you'll just type it into your calculator. Guys, negative log of 2.3 times 10 raised to the negative 2 power. And you get pH is equal to 1.6. That is for Coke. Then for Sprite, pH is equal to negative log of 13 raised to the negative 5th. Does everybody understand though? It's because we were given the hydrogen ions, which is H plus. So I'm plugging it in. Do you understand? Okay, so then we have negative log of 13 raised to the negative 5th. And you get 5.56. So This was 1.6, this was 5.6. I rounded, so 5.6. So how many times more intense is Sprites than Cokes? So you'd go like this. 5.6 times what is equal to 1.6? So we divide both sides by 5.6, right? So, oh, I should have done 1.6 divided by 5.6. So I should do 5.6 divided by 1.6 to see how many more times intense. So it's 3.5 times more acidic. Comparing, it just kind of, that's the hard thing is I sat and thought about this one. I'm like, what are they really asking for? This is the pH levels of Coke. This is the pH levels of Sprite. So it says, what's the difference? Well, really you'd say, okay, then Coke or Sprite is 3.5 times more acidic. Does that make sense? Kind of. Okay. I didn't explain it very good, unfortunately. So do you see how, you guys understand how I found the pH levels of both, right? Take the big divided by the small. That's how many more times acidic it is. Do 10 and 11. So it says, number 12, I'll do it with you even. Number 12, a liquid solution has pH, wait. Did you already do 12? No. Okay, a liquid solution has pH of 9.2. Find the concentration of hydrogen ions. This is one of the most missed ones on the test. It's one of the easier ones, but it's because people plug in the wrong thing. So this time we're given the pH level. Does everybody understand how this time we're given the pH level? It says the pH is 9.2, so wouldn't that go right here? So this is 9.2. So 9.2 is equal to negative log of H plus. Now it says, what is the concentration of hydrogen ions? So we're solving for H plus. So in this one, we've got to isolate log. We'll divide both sides. We've got to get rid of the negative first. One of the most common errors on the test. Get rid of the negative first. Divide both sides by negative 1, right?
Yeah.
So negative 9.2 is equal to log of H plus. How do we get H plus along? We got to get rid of log. How do you get rid of log? You take the base 10 of both sides, right? Log of the base 10 and base 10 cancel out. So on the left, we have 10 raised to the negative 9.2 is equal to H plus. Those are our hydrogen ions. Type it into your calculator. 10 raised to the negative 9.2, and you get 6.3. You get 6.3 times 10 to the, so when it says E, you guys all understand that means times 10, right? So times 10 to the negative 10 is equal to H plus. That's our answer. If you got questions?
So we're working backwards.
Yeah, we're working backwards. Yep. So do number 13, and that's all it's required to do up till tomorrow. Do it though. Don't put anything away until you're done with 13 and the whole other 2 pages. Do you all understand? Then we'll finish up the half-life tomorrow and learn tomorrow's lesson. Sound like a good deal?